Einstein's general relativity, the very cathedral of modern cosmology, harbors a dirty secret within its limestone pillars. The equations that govern the curvature of spacetime, the orbits of planets, and the crushing gravity of stars possess a disturbing symmetry. They do not care about the arrow of time. In the cold logic of the field equations, the past and the future are interchangeable variables. If you take the mathematical film reel of a black hole, an object so dense that space folds in on itself, and you run that film backwards, the equations do not break, they behave perfectly. But they result in an object that defies every instinct of physical reality. You get a monster that is the exact mirror image of the abyss. You get a white hole. This is not merely science fiction or a convenient plot device. It is a rigorous prediction of the Schwarzschild metric, the very first solution to Einstein's theory. Where a black hole is a region of space-time defined by an event horizon that nothing, not even light, can escape, a white hole is defined by an event horizon that nothing can enter. It is the ultimate cosmic exclusion zone. Gravity here is repulsive in a way that shatters our understanding of attractive force. Light and matter can careen out of it, ejected from a singularity that acts not as a drain, but as a fountain. Yet no force in the universe can push a single proton back inside. It is a one-way door, locked from the inside. For decades, this mathematical ghost haunted the chalkboard. Physicists dismissed it as a vacuum solution, a technical artifact with no counterpart in the messy, real universe. They argued that while the math allows it, thermodynamics forbids it. Entropy increases, things fall apart, stars collapse. They do not spontaneously uncollapse. A white hole seemed to require a star to unexplode, gathering light and gas from the corners of the cosmos to form a singularity, which is statistically impossible. So we ignored the ghost. We treated the black hole as a dead end, a place where the story of matter simply stops. But the universe rarely tolerates a dead end. The problem lies deep within the black hole itself, at the singularity, that infinitesimal point of infinite density where gravity becomes infinite and the laws of physics divide by zero. General relativity predicts this point, but it also breaks down there. It cannot tell us what happens at the center. It predicts its own demise. This silence at the heart of the theory suggests that our picture is incomplete. If gravity creates a puncture in space-time, does that puncture stay open forever? Or does the fabric of reality have a mechanism to heal itself? The existence of the white hole in the mathematics might not be a quirk of the pen, but a glimpse of the machinery we have yet to observe. It suggests that the singularity is not a termination point, but a transition gate. The ghost might actually be the other side of the coin, waiting for the moment when gravity's relentless inward march hits a wall it cannot break, forcing the entire system to flip. We have spent a century staring at the drain, oblivious to the faucet. From that mathematical paradox emerges a solution that might just save physics from its own breakdown. The bridge between the abyss we see and the fountain we calculate lies in the realm of the very small, loop quantum gravity. This theory, a leading contender for the unification of quantum mechanics and gravity, proposes that space is not a smooth, continuous sheet. Instead, at the Planck scale, scales so small that protons look like galaxies, space-time is woven from distinct, quantized loops. It is granular, and because it is granular, it cannot be crushed infinitely. When a massive star collapses to form a black hole, general relativity says it shrinks to a point of zero volume. Loop quantum gravity screams halt. As the matter is crushed down to the Planck size, the quantum foam of space-time resists. It compresses like a cosmic spring. The collapse doesn't result in a singularity. It results in a Planck star, a hyperdense nugget of quantum fury. And just like a compressed spring, once the inward pressure is halted, there is only one direction left to go: outward. The collapse effectively bounces. The black hole dies, and in that instant of quantum turnaround, it transforms into its opposite. The event horizon flips. The attractive gravity becomes repulsive. The black hole is resurrected as a white hole. You might ask, if every black hole eventually bounces, why is the sky not filled with exploding white holes? Why do we see the silence of the dark and not the violence of the light? The answer lies in the extreme distortion of time. Gravity dilates time. Near the horizon of a black hole, time slows to a crawl relative to the outside universe. Deep inside, near the high-density core where the bounce happens, the effect is magnified exponentially. To the quantum star undergoing the bounce, the process is nearly instantaneous, a fraction of a second. It collapses and explodes. But to us, watching from the safety of Earth, that split-second bounce is stretched over billions, perhaps trillions of years. We are watching the collapse in extreme slow motion, waiting for a rebound that will happen long after our sun has burned out. This quantum bounce changes everything. It resolves the Hawking radiation paradox, which feared that information swallowed by a black hole was deleted from the universe forever. If the black hole eventually turns inside out, all that information is preserved, stored safely in the Planck star, and eventually spewed back out into the cosmos during the whitehole phase. The universe retains its memory. But the implications scale up terrifyingly. If this mechanism holds true, we must look at the biggest explosion on record, the Big Bang. Our universe began as a point of infinite density that suddenly expanded, spewing matter and energy into existence, a behavior identical to a white hole. It is entirely possible that we are living inside the aftermath of a collapse that occurred in a parent universe. Our beginning was merely the other side of a titanic black hole's end. We are the ejecta of a cosmic bounce, living out our history in the expanding debris of a higher dimensional event.